right. Hey everyone, how's it going? Thanks for having me at Go San Francisco. So we're here to talk about some security issues in Go modules. I've been just as excited as everyone else to be following Go with the 1.13 release and some of the security considerations that were put into Go 1.13. So I'm not going to talk about Go 1.14 that I know was just released during this meetup, but maybe in the next one. So let's kind of talk through the agenda. I know this is kind of a lot, but we're going to run through it pretty quickly. So I'm going to do a brief introduction about who I am and what company I work for and what we're working on. Then I'm going to give you a super brief history of dependency management in Go. We're going to jump into talking about how the GoSum and Go mod files work. I will talk a little bit about how the checksumdb works in Go. There's some other basic concepts that I'll introduce you might be familiar with, but semantic import versioning. And then I'm going to talk about potential issues that the Go checksumdb doesn't really address. And we'll talk about GoCenter and go from there.
Are you going to be posting the slides online?
Yes. So, good question. All right. So if you go to, if you scan this little QR code and you go to, or you go to jfrog.com/show notes, you should have access to all the notes that I put up during this presentation. We're also giving away T-shirts. So this is our way of giving back to the community, but also, making sure you get access to the notes. I will put this slide up at the end when I'm doing Q&A, so if you don't have a chance to go to that link or scan this now, you can do so near the end. Okay. All right, so as I said, I'm Datta. I am the community-focused product manager for JFrog. We are a startup based out of Sunnyvale, and my job is actually to work directly with the developer community on understanding what features and free community-focused products bring value to all of you. I work on Golang and GoCenter, but there are a few other centers at JFrog that I'm also in charge of. So I've got my contact information there, d@jfrog.com. My Twitter, I'm a big fan of talking to people, especially through social and email, so do get in touch after this presentation or come talk to me after my talk. All right, cool. So you probably all know that Go's gone through a few stages of dependency management. One of the early stages of dependency management was called Glide. Go then asked users to place a project folder inside their Go path to resolve Go packages. Go then experimented with a dependency project called Dep. I think Dep is my favorite because it's one letter away from deep. And the community evolved, and Go introduced this concept of modules. So with 1.11, Go modules were first introduced. Modules are a collection of packages, and with Go 1.13, modules became the standard for Go. What's really cool about Go 1.13 is that the Go founders and developers really thought a lot about some of the other issues that programming languages like NPM and then Python, NPM and JavaScript and then Python had. So they wanted to address some of these issues when they built Go modules. The first thing that I'm going to talk about is how the Go mod file works, and then I'm going to talk about how Go.sum works. And I've got little examples here. So you're probably all familiar with what these are, but what I really like here is if I use the go mod init command, these files get auto-generated, right? So go mod init, my go mod file auto-generates. It includes the list of dependencies for my program that I'm creating. And after I run go build, you get an auto-generated list of hashes. So here's where we talk a little bit more about security in depth. So here you have a list of hashes, right? These hashes are used as checksums, which I will explain in a second. Basically, a checksum is a way to provide authentication that a block of digital data hasn't been changed and doesn't have errors that pop up during transmission. By themselves, checksums are usually used for data integrity, and they are not used for, say, code quality. So they can check that your code hasn't been tampered with when it's in transmission or stored or imported later. But checksums don't necessarily look at your entire code base and see where you messed up. With Go, what this does is it helps make sure that your dependencies that were originally committed to your Go module the first time you built it haven't changed when the user goes to download your module at a later time. So I'm going to talk a little bit more about how this works in 2 more slides, but wanted to introduce SHA-256 checksums. So GoSF files create a SHA-256 base 64 hashes, and SHA stands for the Secure Hash Algorithm, and it's actually probably now one of the most common types of hashes used. This is because it's pretty much unbreakable, it hasn't been broken yet. And I am not a cryptographic expert, but generally it works by creating a system of mathematical equations that provide bits of output on one end. So you basically put in a file or plain text file, an image, it can really be anything. It goes through the hashing function and it spits out 43 characters. So no matter what you put in on the left, you're going to get a SHA-256 hash on the right. And what's important to note is that a single character difference in the underlying file produces a very different looking hash. So this makes SHA-256 amazing to use as a checksum. As you can see there, what's important about these SHA hashes is that they're irreversible and unique. You cannot go backwards from a hash. So if you only have the output of the hash, there's no way to go backwards and figure out what the original file was. And of course, unique means that, again, if anything's changed, the whole hash will change, and the hashes can look very different, even if you change one word or one character.
Can you also define them all?
In Golang, you can create your own hashes, but those aren't 512 aren't auto-generated. All right, so here we go. So let's say you have 2 Go modules, right? Module 1 and Module 2, they both have a go.sum file. And so what's going to happen is the list of hashes in your GoSF file for Module 1 is going to look totally different from the list of hashes in Module 2. And this might be because 1 or 2 characters are different, but usually you have different dependencies for different modules. So what happens here is Golang has a database. It's called GoSumdb. It's a checksum database. And when you build your app, the GoSum file goes to the database and it commits it. And later on, it'll match those hashes. For your module 1 is the same here, module 2, same here. This will make more sense in a second. All right, so you can probably read that, but to say it another way, Golang has a trusted database that can be checked and audited. You can actually publicly audit the database. This allows, generally any developer to make sure that what's being logged here is correct and legitimate. I think this is a pretty special part about what separates Go modules from other dependency management tools. And the real point here is how hashes protect you is if you have your module 1 and later down the line you or someone else makes a change to that module, the hashes completely change, right? So you can say, if somebody else wants to copy your code and inject some vulnerability and try to commit it as the same module name, the hashes won't match. And this will cause a checksum mismatch error. Users, first of all, they can't they can't commit that module 1 that they changed as the same module, and users down the line, when they're looking for your module, they're not going to be downloading someone else's. So this is great because this ensures the developer cannot inject new issues or vulnerabilities into the same module version. So let me show you kind of an example of how this might play out in the real world. All right, so I'm a young developer, first-time developer, and creating my first Go application. So I import a bunch of dependencies, and I build my first module, call it mod1. So Golang is going to auto-generate my Go mod file, and then my GoSum file, and commit those list of hashes up to Google's database, again called GoSumdb. But what happened is I just realized that I imported the wrong module, essentially. So this module right here, text template, actually is going to introduce a small vulnerability into my code. This is going to introduce a cross-site scripting error. So cross-site scripting occurs when user input is used as output into the browser without being encoded. So this is going to allow information from my Go mod, and when I inject into the browser, it's going to be encoded. It opens up your future apps with vulnerabilities. So attackers can actually use this to inject code in browsers, and XSS attacks can be used to redirect users to phishing sites, steal cookies, and steal session information. So what do? I've already committed my mod file to Google's database. Well, I can come back and I can fix the file, and I can create a new version. So here I've actually imported now the right dependency. I fixed the file, that vulnerability is no longer there. And normally this would probably be upgraded to a patch version. But just in this example, I'm going to call it mod1 version 2. So whenever you create a new version of your module, you have to use something called semantic import versioning. It's really just a fancy way of saying you have to follow the standards of how Google is looking for new versions of your modules. So if I create a minor release, the version number will change in the decimal places to the right of the v1. They can be updated. They'll be updated in my import path. And if I create a major release and call it version 2, you're going to notice that version 2 import path changes a little bit. Now there's a slash in front of the v2. This way that the way that you label new versions is extremely important with Go 113. So it's something to pay attention to, and this is actually sometimes an issue when converting from Go 112 to 113. So I just wanted to point that out. All right, so what happens now? So now I've got my two modules, right? I have my mod 1, which has that cross-site scripting vulnerability, and I've got my mod 1 version 2. And you're going to notice that each version has a different list of hashes, so there's no risk of them clashing when they're committed to GoSumdb. So this is pretty great. I can inform all my friends that, hey, I actually fixed an issue. Don't use mod 1, use this other version right here. But what happens in the real world is, you're creating apps at different times, you're importing dependencies at different times. And depending on your Go proxy, you might not be getting your dependencies updated in terms of the version in real time. So this is an issue because if someone imports my module and it's still mod 1 in this example that I'm showing you, they open themselves up to a cross-site scripting attack. So this is a simple example, but what I really want to get across is imagine if you have all these dependencies in your Go module and you're not necessarily paying attention to when each dependency version was updated. This is a very real thing that happens, and this is actually why we are working on increasing how we look at vulnerabilities in Go modules in GoCenter. Okay, cool. So let's quickly summarize what I just talked about. So I introduced the GoSum file, which is a list of SHA-256 base 64 hashes. Talked about how GoMod stores a list of each dependency, and as you know, your Go command can use these hashes to detect misbehavior in the origin server or proxy. But what does this really mean for Go modules, and how do you keep them free from vulnerabilities? This is kind of why I am here. All right, so I'm going to introduce JFrog GoCenter. I'm going to give you a demo in about 30 seconds. So GoCenter is a module mirror. It's a free Go proxy. You guys can go to GoCenter.io. You can search for modules. You can use it right now on your, obviously you don't need to use it on your phone, but you can look it up on your phone, and when you get home, you can find any module information you want. GoCenter has over 80,000 modules and more than 600,000 versions of those modules. And now with vulnerability scanning, which is a JFrog product, it's a feature of JFrog's Xray security tool. Now that we have free vulnerability scanning of Go modules, you can actually check that any module version that's publicly available, you can check what version might have a vulnerability or might not. GoCenter periodically scans the entire web and adds new modules and new versions. It also will add new modules when somebody is specifically searching for that on GoCenter. You can also, as a module author, add your module using our add module inclusion process, which is pretty easy. So to use GoCenter, you can just go to the UI and search, and you can also, in your terminal or in your app, you can use GoCenter as a Go proxy. You just update your environment variable, you do export Go proxy equals https gocenter.io. Right, so let me show you a little demo of how the vulnerability scanning in GoCenter actually works. So, move the mouse over here. Right, cool. Right, here we go. All right, here's GoCenter. And you're gonna see we've got a search bar, you have the add modules, and we have this little fun Gopher cartoon thing. The first thing to know about GoCenter, again, is it's completely free and you can search for any module you want. I end up always kind of searching for the same ones. You get the top 10 results. You're gonna see obviously the name of the module. You're going to see the latest version, including pseudo versions. You'll see the number of stars and downloads. This helps you kind of understand which modules might be the most popular. So if we go to the Go module UI, we have all this metadata available for the modules. So you can see the license information, the downloads, and you can see dependencies, mod file, etc. I am not here to show you everything about the GoCenter metadata. I actually want to show you about the vulnerability scanning. So we're going to go to this module that I know has vulnerabilities, Moby. And when you go to Moby, you're going to see the security tab has lit up and it's got a little warning triangle on it. So in GoCenter's UI, when you see that warning triangle and you see that color, you're going to know there's vulnerabilities for this module version. And here you're going to see a list of all the vulnerabilities found in the Moby module, the latest pseudo version right here. You can actually go to any version that's publicly available. GoCenter caches them all. Moby tends to have vulnerabilities in a lot of the recent versions. So here we have CVE information. This is an ID that indicates what the vulnerability is. We have a severity level, medium, low, medium, high. We also have a brief description of the vulnerability. This is the information that we provide in GoCenter. If you want sort of like remediation steps and more information, you can check out Xray by clicking here. We're not going to do that today. What I want to show you that's really cool about the security tab for these modules is we don't just show you, security for the one module that you're searching for. If you go into the dependencies tree, you can drill down. If I can't find one, I will go to the one I know.
Sorry. Why do we have disclosure triangle?
This is so it's like a lazy load. So it's a little funky in that way. Let me go to the one that I know of. Hold on 1 second. Go back to my presentation. Okay. All right. Oh, there we go. So console has one in its dependency tree. All right. So let me go back. Okay. So here, you go to the console module right here. You notice that this actual module does not have a vulnerability, but one of the dependencies of console does, right? So this right here, core DNS version 1.1.2, there is a vulnerability, or perhaps more than one here. So what's really cool about the dependency tree is you can click on any dependency. It will then redirect you to the actual page for that dependency. And so here I am on core DNS, and you're going to see again, security tab. Yes, there is one vulnerability in this module. I think if I select a different version, you're going to see, other versions may not have vulnerabilities. A much easier way to see this in the UI is going to the versions page. So here on the versions page, you're going to see, again, you're going to see every version of this specific module, including pseudo versions, and you can see which versions have vulnerabilities and which do not. All right, cool. So I'm going to go back to the presentation. I will now wrap up that demo. I wanted to just briefly explain, if you're not familiar with how the security stuff kind of works, the vulnerability data that is in GoCenter and Xray comes from the NVD. The NVD is the U.S. government's repository of standard vulnerabilities. This list of CVEs, these are called the common vulnerabilities and exposures. Again, there is a CVD ID number associated with every vulnerability that's been publicly found. This CVE database or list is really also supported by the U.S. Department of Homeland Security. And I specifically screenshotted this because these are CVEs that have to do with cross-site scripting issues, similar to the one I showed sort of earlier today. And GoCenter, again, provides you NVD information and CVEs for free. JFrog also has a paid solution that gives you a lot more vulnerability scanning data from proprietary databases such as VulnDB. Ooh. Okay, so we're going to start wrapping up. I want to just wrap up with kind of coming back to the story we were telling. So we have our two modules, right? We have mod 1 and mod 1 version 2. As you know, as I explained, mod 1 has a cross-site scripting issue, and so we've shown you the little vulnerability triangle. And again, here on the versions tab of GoCenter, you can see which versions of these modules are vulnerable and are not. Okay. The last thing I wanted to show you before I end is we just introduced vulnerability scanning in GoCenter about a month ago, and we're slowly working with the community to improve the UI, to improve how we explain and show vulnerabilities and CVE information. We're also going to be putting this information in your favorite IDE, my favorite IDE, VS Code. It'll be coming out in, say, 2-3 months. And what we're trying to do here, again, is we're trying to help Go developers write in the tools that they already use. So what's going to happen basically is you're going to be able to see when you're building your modules, when you import a module with a version that has a vulnerability, you're just going to have this little squiggly line that appears. When you hover over it, it's going to provide you the severity and the latest version that's been fixed, and then it'll link you back to GoCenter so you can see all that other information about this module. I want to say that if you guys watched this presentation and you have any thoughts or feedback, not necessarily about the presentation, but you can give me feedback about that too, but if you have any feedback about how you'd like to see the security information or if you have other ideas, I really do want you to get in touch with me. Again, we're building all of this with the community. We're building it as we go. So to give us feedback about these features, you can email GoCenter@jfrog.com. I checked that email, but you can also reach out to me directly at deepd@jfrog.com, or you can tweet at me. I use Twitter like every week. Every week, I know. I don't have a life. Just kidding. So please do reach out to me. You can talk to me right after this talk, and we're going to jump into Q&A. As I said, I'm going to leave this up while we're doing questions and answers. If you'd like a free Go t-shirt, these are JFrog Go t-shirts. They're actually really cool. I didn't wear mine today. You can win one. We're giving out 3. Okay, so that's my talk on security and vulnerability scanning at the GoCenter, so thank you. What questions do you have for me? Go ahead.
So is there any way of getting access to, I assume it's a VS Code extension that you're going to have out. Is there any way of getting a beta version of the VS Code extension so people can use it and then provide you with feedback? And if not, where would you go to find out when that VS Code extension has been released?
That is a great question. We haven't planned on creating a beta first, and the reason is because a lot of the vulnerability information that's going to be put into the VS Code extension, it essentially already exists in GoCenter. So we really think we're just extending the capabilities of GoCenter into VS Code. But that is something I can keep in mind. We will start talking about the VS Code extension in, I'd say, about 4 to 8 weeks. You can learn more about it on the GoCenter blog. So go to GoCenter.io and you go to the blog, or the wiki page, or the GitHub page. GitHub has a wiki on it. We will talk about it there. And you can also email me, and I can keep you updated. You had one other part to that question, right?
It was beta and when it will be released.
Right.
Where to go for a notification, so I can email sign up, watch your Twitter.
Right. Again, the best thing to do is to email me for meeting information or check the GitHub wiki pages. The other part of your question was sort of, can I see how this works in the IDE? So right now, we plan on making the free vulnerability scanning in GoCenter part of the JFrog extension itself. So you can actually download the JFrog plugin in VS Code already. You're not going to get the vulnerability scanning, but you'll get some of the other JFrog metadata available. When the GoCenter vulnerability information is released, it's going to be part of that plugin, and it'll be free again. Yeah. Any other questions?
Yeah. If you have private repos, is that going to stop you being able to use the Go proxy as is, and what's the solution?
Great question. So if you have, modules in private repositories, will that stop you from using GoCenter? And I think you're asking also about the vulnerability scanning part, right? If you have a private repository and your modules are not publicly available, then we will not scan them, right? So they have to be publicly available. Usually that means they're up on GitHub. That's where we ingest these modules. If they're private, we obviously don't have access to them. You can use GoCenter. You can set up GoCenter actually with a private repository. So JFrog's premier product is Artifactory. It's a central repository, and if you'd like, you can set up your own private repos in JFrog Artifactory, and it will automatically connect to GoCenter as your Go proxy. You can also connect it to the actual Golang as a Go proxy as well. And Artifactory supports more than just Go modules. It has like 27 different package types. So if that's something you would do, you can check it out. Any other questions before I wrap up? Yes.
Yes, twofold question. One is, what do you expect the lag to be between the CV being public and appearing in your scanner? And the second question, can I get notifications if I, for example, post a list of modules I depend on and one version gets an alert?
Great questions. I'm going to answer the second one first. We do not have notifications right now on GoCenter UI or VS Code. but we're planning on adding it probably later this year. So eventually there's going to be some kind of notification or subscribe button. The idea is we're going to send you a report of the vulnerabilities that you signed up for. First question, when do we get the CVE information? I believe it takes us less than a day, maybe about a day or two, to get it into GoCenter once it's been publicly listed on the CVE entries list. Let me do one more question if anyone has anything else for me. No? Going once? Okay, thank you guys again for listening to my talk. Again, I'm always available if you email me. I promise to email you back within 24 hours, unless I'm on vacation. So thanks again, and enjoy the rest of this evening. Bye.